Hi everyone, you should have covered the cardiac cycle already. So this is all about the electrical control of the cardiac cycle. There's a couple of things you need to start off with. First off, the heart itself is myogenic, as in it's generating its own impulse. This means that the heart will continue to beat even if it doesn't receive impulses from the brain. Now, it's not beating fully, as in strongly, but it will continue to effectively quiver for about 10 minutes after the impulse from the brain has stopped. So, after a person dies, they have about 10 minutes where their heart continues to quiver. An interesting fact, cocaine addicts, when they die, their heart will continue to beat for about 20 minutes after their death, due to the fact that cocaine is such an extreme stimulant. So it's myogenic as opposed to neurogenic, which is arriving by nerves from the brain. So self-originating in the muscle itself. The cycle itself is split into three, and each originates in a different area of the heart. The first being the sinoatrial node, which is often referred to as the SAN or the natural pacemaker. Then you've got the atrioventricular node, also known as the AVN. That's between the atria and the ventricle, as we'll see in the next couple of diagrams. And the last thing is the bundle of His, which has no abbreviation. Off of the bundle of His, there is the Purkinje fibers. They're not really mentioned very much in the specification in the book, but they are handy to know. So from GCSE, you should know that the impulse in the heart itself starts in the right atrium there, that blue spot roughly being circled there by that arrow. It then travels from there to the AVN, which is often represented in the center, but is actually slightly offset, and then it travels down the bundle of His there and there. It's a branching structure into the Purkinje fibers, which cause contraction of the heart from the apex, the bottom, upwards. This ensures there is an even ejection of blood out of the two blood vessels, the aorta and the pulmonary artery. So, simplified diagram, the SAN is there in the right atrium, the AVN in the center on the septum, and the bundle of His with the Purkinje fibers, which are not shown in the diagram, travelling down the septum to the apex and then branching left and right. It starts by the SAN releasing an electrical impulse, an action potential is the correct term, across the entirety of the heart. This would cause the whole heart to contract at once, but the thing is, there is actually a system of blocking fibers, these non-conductive tissues, which are represented there by the dotted line, which stop the impulse getting to the bottom of the heart. Otherwise, the heart would squeeze in one go, and that would cause a lot of problems. Those fibrous tissues there literally block the impulse from getting to the apex in one go. However, we do need that impulse to get to the apex. So this is where the AVN steps up. The impulse strikes the AVN and it actually slows the impulse down there. It's allowing contraction to catch up with the impulse. Basically, the impulse is incredibly fast. Muscle contraction in relation to that is quite slow. After it's passed through the AVN, the impulse is then transmitted down the bundle of His. It's contained within that. It does not effectively permeate into the tissue there. It only does that when it reaches the apex, where it then causes contraction from the apex upwards, effectively pushing all the blood out, as mentioned before. I like to think of this as like if you squeeze a tube of toothpaste from the bottom upwards, all the toothpaste comes out in one go. It's exactly the same with the blood in the heart. You want to get it all out in one squeeze effectively. To assist this, we have the Purkinje or Purkinje fibers, which permeate through that, which ensure even distribution of the impulse. What people don't realize is how hard the heart actually contracts. There's a video attached here, I'll share it with you, which shows this really nicely. It also shows the ECG, which I mentioned in the last lesson. The final section is control of the heart rate. This is actually coordinated by two separate but connected control mechanisms, one being the nervous system and one being the hormonal system. It is often the brain that determines heart rate, but hormones can as well, such as adrenaline. By the way, that's the worst tattoo ever. This is all part of the autonomic nervous system and helps to regulate it. Just to finish off on, quick thing about ECGs. I know I covered them last lesson, but this shows where each stage of the ECG is permeated or detected in the heart. So it starts with diastole, moves into atrial systole, that little bump there, then ventricular systole, the big spike, and then finally dispersing of the electrical impulse through the heart tissue, which is that final little bump. And if you're interested, I'm going to share the time warp video, which I reworded to link to the cardiac cycle. You don't have to watch it, it's just a bit of fun. Thanks a lot. Bye.